A quadratic function is a function in one variable in the form f of x equals ax squared plus bx plus c, where a, b, and c are real numbers and a does not equal 0. Another way to say that is the standard form of a quadratic function, which is basically just the f of x equals ax squared plus bx plus c. The first example, the base of a rectangular window frame must be 1 foot longer than the height. Which of the following is an equation for the area of the window in terms of height? Okay, first of all, it is a rectangle, and the area of a rectangle is base times height. The base is 1 foot longer than the height. So we don't know, and it is a function, so I'm going to use a of h. I'm using the h because we don't know what the base is. We know the window in terms of the height. So that's how we want to write our function. So we know that the base is 1 foot longer. So whatever h is, you're going to add 1 to that times the height. So that's going to be your equation that you come up with. So this is the answer here. Okay, the next one. Which of the following is an equation of the area from an isosceles right triangle in terms of the base? You'll have to give me a moment. I'm just getting used to this tablet. Okay, this is the area of a triangle, and the area of a triangle is 1/2 base times height. But again, it's a function in terms of the base. So this time we're going to do the function a of b for base equals 1/2. Now when you're talking about the area of the triangle, look for the box if it's a right angle, because that is pointing to the two sides that you're going to use for your base and your height. So as you can see, they flipped this thing over. So I'm just going to do b times b, which, I'm sorry, function notation. B times b is b squared. So that gives me 1/2 b squared. So that would be the answer there. Ben is creating a triangle that has a base that is twice the length of the height. Write an expression. Okay, an expression has no equal sign for the base of the triangle in terms of the height. So I'm not going to write the function, I'm going to write the actual expression. And how I do that is, let me just sketch out the situation over here. And it doesn't have to be a right triangle. I'm just going to use a right triangle for an example. So we know in a right triangle the bottom is the base and the altitude is the height. But we don't know what the base is. We just know that the base is twice the height. So I'm going to substitute the base in for 2h. So for this one, write an expression for the base of the triangle. So that's really the answer to that one is 2h. Okay, the next one. Write the function for the area a of h in terms of the height. So again, the area of a triangle is 1/2 base times height. But they asked for a function in terms of the height, so I'm going to do a of h equals 1/2. We just said we don't know what the base is. We called it 2h. And the height was h. So half of 2 is 1. And if the coefficient is 1, if you have variables, you do not have to put the leading coefficient of 1. You don't write it down. So I'm just going to leave out the numerical part and do h times h, which is h squared. So for this scenario, that is the equation for the area. Complete the table and then graph the function. So we're going to use this equation into this table. So literally you just do 1 squared is 1. 2 squared is 4. 3 squared is 9. 3 times 3 is 9. Four squared is 16, and 5 times 5, or 5 squared, is 25. Now they want us to graph this function. Well, the first thing you want to do is look to see what your scale is, and the y values go to 25. So I'm just going to make a scale of 3 so that I can fit most of the points on this graph. If you're going to do that, you can do that. You just got to tell me what your scale is. So by putting it on each corner, you're telling me what this is. And remember, this table, this is the H, and this is the area. Okay, so we said 1 goes to 1, so I'm going to put that at about right here. And obviously 0 goes to 0, because if you don't have anything, it's not going to measure any. It's not going to have an area. 2 goes to 4. I'm going to put that about right here. 3 goes to 9. 3, 6, 9. 4 goes to 16. 12, 15, 16. And 5 goes to 25. Well, we can't fit that on here because it only goes up to 21. Here's the problem though. Here was our equation. A of h equals h squared. Now we know, because of the 2 is the highest exponent, it's the degree, we know this is a quadratic equation, but if you look at our graph, we do not have a quadratic function. We only actually have the right side of the function. So quadratic functions show symmetry. So if you come on the other side and make your dots in the same location on the other side, the best that you can, then you can make your quadratic curve. So your graph should be a parabola. So make sure that that bottom part is definitely a curve and not a V, because if it's a V, you've just made it an absolute value function.